Hi guys, welcome to the step-by-step instructional video on how to prove that if two triangles ABC and DEF are similar, then their sides are going to be proportional. Okay, so this proof is going to be structured in a similar way to a lot of Leaving Cert proofs, where we're going to have a given to prove construction and proof. And if you're unclear about what any of those words mean or why they're structured in that way, check out this video because I go into that in quite a lot of detail. Okay, so let's get going. What I have in front of you here is the given part of the proof. Okay, this is the context of our proof. We have two triangles that are similar. Okay, so let me just write that much down. Now this is, when I say given, this doesn't mean that in the exam you're going to be given these triangles, you still have to draw them, but this is the context of our proof. So let's just do that much. So given two triangles ABC, triangle ABC, and DEF, triangle DEF, in which angle A equals angle D. Okay, angle A equals angle D. Angle B equals angle E. Angle B equals angle E. And angle C equals angle F. Okay, so this is the context of our proof. This is what we're starting the proof with these two triangles which have three of the same angles. Okay, that means that the triangles are similar, because that is a definition of a similar triangle. But what actually is a similar triangle? Let's take a minute to think about that. Okay, similar triangles have all the same angles, and what they actually are is that they are the exact same triangle at different scales. Okay, it's like saying that if you just focus on this triangle on the left here, and I just zoom way out for a second, this little triangle is similar to this one, which is a lot bigger. Okay, so if we measure, the size of this triangle on our screen, it's a bit bigger. If we measure this as, this might be 4 centimeters rather than being, half a centimeter, but it's still proportionally the same triangle. It's just a different scale. It's just zoomed in and zoomed out. So that's what similar triangles actually are, guys. Okay, it's just different triangles at different proportions, and that's actually what we want to prove. We want to prove that these triangles, which are similar, are actually the same triangle at different scales. Okay, so we want to prove that the sides, the length of the side AB, the length of the side AB over the length of the side DE is equal to the length of the side BC over the length of the side EF, and this is equal to the length of the side AC over the length of the side DF. So to show that these triangles are proportionally the same thing, what we've actually decided to do to show this is to show that all the corresponding sides, right, the sides that have an angle, the same angle at the top and the bottom, okay, that the corresponding sides are in the same ratio. All the corresponding sides are in the same ratio. Let me show you a little bit of that, what I mean, okay. Let's say I just, for example, I call this, let me just zoom in a bit. Let's just take a moment to do this. Okay, let's say I call this X, and I called the corresponding side here Y. I called this one P, and I called the corresponding side here Q. Okay, now let's say that X and Y are in the ratio of X to Y. If these triangles are proportional, then all the corresponding sides will be in the same ratio. So the ratio of P to Q is going to be the same. Similarly, the ratio of A to C, D to F will be the same. Okay, so it's about ratios. And another way that you can express ratio is you can express it as a fraction. That's actually another way that you can show that ratios are the same. And if you're unclear about why that is, I go into that in more detail in this video. Okay, so check that out if you're not sure why that is, or if you haven't seen that video already. So if X to Y is the same as the ratio of P to Q, then X over Y is going to equal P over Q. So that's why we've decided to prove it in this way. We've said that the one corresponding side over another corresponding side will equal to all the other corresponding sides over each other. Okay, because we're saying that they're in the same ratio, we're saying that the triangles are proportional because they are similar. Okay, let me clean this up a bit. Okay guys, let's do the construction. So what we're going to end up with is something that looks like this, okay? We're going to get our dotted line, put it in between here, and the point that the dotted line touches on the side AB is going to be the point X, and the point that the line touches on the side AC is going to be Y. And we're going to have constructed this in such a way that the distance AX is equal to DE, the distance AY is equal to DF, and then you're joining X and Y. Okay, so what do we write down for this part of our proof? So we're going to do the following. So mark the point X on AB such that AX is equal to DE. We also then want to mark the point Y on AC such that AY is equal to DF. And the last thing is to join X and Y. Then join XY. Okay? So we're marking the point X such that AX equal to DE. We're marking the point Y such that AY is equal to DF, and we're just joining those lines. Okay. So the first thing to notice, guys, in this proof is that the triangle AXY is congruent to DEF. Congruent is a fancy way of saying identical. Okay? So let's get that much down first. So the triangles AXY and DEF are congruent. And the reasoning I'm going to give for this, right, is simply SAS. Okay, what does that mean? There are three ways that a triangle can be congruent, that triangles can be identical. SAS is one of them. Okay, it means side, angle, side. It means that one side is the same, another side is the same, and the angle in between that side is also the same. And if two triangles have those properties, then they're identical to each other, or they're congruent. Okay, AX is equal to DE, AY is equal to DF, angle A is equal to angle D, therefore these triangles are congruent, they are identical. Okay, so saying SAS is enough reasoning, okay, for why this is true. So if those triangles are identical, therefore the angle AXY must be equal to the angle DEF. Okay, angle AXY is equal to DEF, because remember, these are not identical triangles, so those are just corresponding triangles. So I am just going to mark in here that this is actually the same as angle E now. And similarly, guys, we can also say that DFE is the same as AYX, so I'm just going to mark this in as angle F straight away, because these are identical triangles now. Cool. And the reasoning for this, we can just say, is corresponding angles. Okay, lovely. Now we already said that the angle B here was equal to the angle E, and if these angles are not equal to each other, then these ones must also be equal to each other. So therefore, angle AXY is equal to angle ABC. Okay. Now, if angle E is equal to angle B, then from geometrical properties, this line XY must be equal to the line BC. Okay, if these were parallel lines, these angles would have to equal to each other. So because these angles equal to each other, these lines must be parallel. So therefore, XY is parallel to BC. Now guys, the shorthand for parallel is just two straight lines next to each other. It means parallel. Okay. Therefore, now guys, this is the next property is going to invoke a proof that is also on the Leaving Cert syllabus, and there's another video where I do the proof, and if you haven't seen it already, you can check it out here, okay? And it is the following: that AB, excuse me, over AX is equal to AC over AY. And the reason for this is because a line parallel to one side divides the other in the same ratio. Okay, let's have a look. So if we have a parallel line here that's parallel to a base of the triangle, then it splits both sides in the same ratio. Okay, that's all it's saying. Okay, and I have that proof done for you in another video, so check that out if you haven't already. Okay, so guys, we already said that AX was equal to DE, AX is equal to DE, AY is equal to DF, so therefore AB over DE is equal to AC over DF. Okay, so we've got quite a lot of proof done already. Now similarly, so we can do this in proof sometimes, guys, where instead of doing out every single part of the proof, we can show one way of doing it, and then we can simply say, okay, similarly, we can also show this. So we're using a very similar method, we can show this, and that's a totally fine and valid thing to do in maths. So we can next say, similarly, it can be proved that AB over DE is equal to BC over EF. Therefore, we end up at our final result, which is that AB over DE is equal to BC over EF, which is equal to AC over DF, guys, and you've made it.